Imad, and I'll be discussing about my Unit 3 mid-unit assignment. So without further delay, we'll look into the questions. So the first question is, describe what happens to the domain and the range of a logarithmic function under a vertical reflection. Support your explanation with diagrams. Here I have chosen the logarithmic function as y equals log ax. First we need to draw the graph and then we can determine the domain and the range. So the graph is drawn over here for y equals log ax. Here now we can see that there is a vertical asymptote at x equals 0. The domain and the range is given here. If we draw the vertical reflection, the function represents as y equals minus log ax, and the diagram is drawn over here for y equals minus log ax. The domain and the range is given here. We can conclude that there won't be any changes in domain and the range of a logarithmic function under a vertical reflection. So we'll look into the second question. Describe what happens to the domain and the range of a logarithmic function under both horizontal and vertical translation. Support your explanation with diagrams. Let's consider y equals log ax as basic graph, and then we can undergo the transformations. After obtaining the relevant graphs, we can determine the domain and the range. The diagram for y equals log ax is drawn over here, and the domain and the range is given here. First we will have to consider the horizontal translation. It occurs in two ways, either to the left or to the right. If we consider a shift to the left side, the horizontal shift to the left side by d units, it can be expressed as y equals log a bracket x plus d close bracket. Similarly, the vertical translation also occurs in two ways, either upways or downways. If we consider a graph shifting vertically upwards by b units, it can be expressed as y equals log a open bracket x plus d close bracket plus b. And the diagram is drawn over here. The domain and the range is given here. Now we can conclude that when logarithmic function undergo both horizontal and vertical reflection will affect by changing the domain, but the range will remain unchanged. Now we'll look into the third question. The graph the function fx equals half log x minus 4. Question number A. Graph the line y equals x on the same grid. To draw the graph of the logarithmic function of y equals half log x minus 4, first we need to determine the basic graph. So the basic graph is drawn over here for y equals log x. The next step, we have to determine the transformation that needs to be done for the basic graph to obtain the graph for the function we want. Vertical compression by factor of half, vertically translation of 4 units downwards. 4 units downwards. Okay, so we'll look into the question number B. Question number B. The graph the inverse function of f inverse x by reflecting of fx in the line y equals x. So the diagram is drawn over here for the question which is being asked, and the question number 3 is about determine the domain and the range and the equation of asymptote of f inverse x. So the domain, range and the asymptote is found over here using the above diagram. Now we'll look into the question number D. Determine an equation for f minus x inverse. So the answer for the D question is, to obtain the inverse function we have to follow two kinds of steps. Firstly, we have to swap x and then we have to solve for y. So instead of fx we have to substitute y, and we will have to work out to find the y value. So we have found the y value over here, and that's it for the unit 3 midterm mid-unit assignment.